1.8, this is really simple. Just even further extrapolation of the last lesson. Before I taught you how to add and subtract vectors using the magnitude, but we have to get into component form. Then doing so, we can add them using the distance or hypotenuse formula. So before, which I actually didn't do because I taught the quicker method or the more advanced method. Let's take a vector of square root 2 again. And let's say it's 45 degrees because I like using special right triangles. Now, instead of saying it's square root 2 in the 45 degrees direction, we could just say it's 1 comma 1. Or it's 1 divided by square root 2 and 1 divided by square root 2 for every length of the hypotenuse. So what we can actually do is we could scale this up infinitely, right? But the logic behind here is that we can add using these objective components. So if we added a vector of magnitude 45 degrees and square root, a magnitude of square root 2 with 45 degree angle here, instead of using this component, which really you can only add things of the same value or things of the same angle. So if we added another one of 45 degrees, we can add like square root, we can add like 30 here or whatever this length of this vector is. We can add them together because they're in the same degrees. But what happens is if we use a vector that is at a different degree angle, the resultant vector is actually going to be the shortest distance between the 2 points, which we can't calculate based on just the hypotenuse. So what do? We break it down into its scalar components. So here we just defined it as 1, 1. So that means we can add the other vector, and let's say the other vector is going to be a 30, 60, 90 triangle. That doesn't look anything like a 30, 60, 90 triangle. 60, 30. We can denote this as 2, 4, 2 square root 3. So instead of adding 4 and adding 4 here at an angle of 60 degrees, instead we can just add these 2 points. So we'll just add 2 square root 3 here. And doing so, we can extrapolate this to 1 plus 2 and square root 3 plus this height. Wait, sorry, let me just make this cleaner. So now we can extrapolate this to 1 plus that square root 3 that was added on top. So it would be 1 plus 1 comma 2 comma 2 square root 3. Actually, that should be 2. So now we can add this as 3 comma 3 square root 3 and guess, oh sorry, that's not how it works. 3 comma 1 plus 2 square root 3. And now we can use the Pythagorean theorem to find out what the length of the resultant hypotenuse is. So that's the logic behind it. You just break it down into its components and add them up. So yeah.